So we are going to discuss the young double slit experiment in today's lecture, right? What is the young double slit experiment? It was experiment. This experiment was done in 1801, right? 19th century it is of. So in this case, what he took the a cardboard. Suppose there is a cardboard. Are you getting or not? Right, and in this cardboard, right, he made the two slits like this. He made two slits like this is the one slit and this is the another slit. Is it clear or not? The two slit. What is the slit? What is the slit? If you consider this is the copy, and if you just tear this with a blade, very small passage, right, very small passage, this is the very small passage, and if suppose this is the light, all right, if this is the light is incident, suppose the light is off, these slits are symmetric. If the light is of point source, when they will reach to this slit, are you getting or not? So, or you may consider they are reaching to this slit, and here if you the screen is placed at distance separation d, this is what? It is the slit S1 and S2, and this is the screen at separation capital D, right? So here what you will get? You will get the consecutive bright and dark fringe. At the center, you get this is the bright fringe, right? And then the dark fringe. This is the dark fringe, right? On the other side also, there is a dark fringe over there, right? This is the dark fringe, then the bright fringe, then dark fringe, this is the dark fringe, this is the bright fringe, this is the dark fringe, right? Bright fringe and the dark fringe, like this. Are you getting or not? This is the bar. So on this screen you will get this type of the fringe pattern, bright and dark, bright and dark, like this. Is it clear or not? So this fringe is called, which is at just center, this is called the central bright fringe. Is it clear, Sanjay? Like this, right? This is the slit S1. This is the 3D view I have made, right? The distance between the two slits is supposed to be small d. This is the small d. This is the source of light. Source of light. When the light is incident from the single source, these two slits acts as a two coherent sources. All right. And after distance d, when the light is incident on this screen after passing through these two slits, you will get consecutive bright dark fringes on the screen. This is the experiment performed by Young to show that the light nature is the wave nature. Is it clear? Copy this. This is the 3D view. Now, to calculate or to find the expression for the position of the consecutive dark bright fringe, we have to do what? This is the 3D view. If just I cut this and I make the figure over here, suppose these are the two slits, right? This is the S1 slit, this is the S2 slit. These slits are rectangular slit, rectangular slits. Are you getting or not? If you cut, this is the cross section, and over here the screen. This is the slit S1, this is the slit S2, and this is the point source. Point source, the light when it reaches at these two sources like this, right? So these two sources act as a, according to the Huygens principle, right? This is the wavefront reaches to this point. According to Huygens principle, every point present on the wavefront act as a new source of light, and in the forward direction, the spherical wave fronts are emerged out like this. So these are the waves which are produced, and when they interfere, interference is produced on this screen. So here the bright fringe, then this is the dark fringe, then it is the bright fringe, it is the dark fringe, bright fringe, dark fringe. All right, this is the dark fringe, this is the bright fringe. Consecutive bright and dark on the left and right side of this central bright fringe, you will get like this. Are you getting or not? This is the dark fringe, consecutive dark and bright fringe you will get. Is it clear or not? Like this, like this, like this. So this is the fringe, right? This is the screen over here. The fringe you will get dark. This is called the central bright fringe. Central bright fringe. Central bright fringe. In short, it is called the CBF. Right? On the both side, this is the first dark one, D2 and D3. In the same way, this is the central bright fringe. This fringe is the B1, this is the B2, right? This is B1, this is B2, right? This is D1, this is D2, and this is D3. So this is the screen you can assume, right? This is the screen. On the screen, this is the central bright fringe, CBF. This is D1, this is D2, this is D3. So if you cut the cross section, right, you will get this type of the things on the screen. Are you getting or not? These are the rectangular strips. On the screen, the consecutive bright and dark rectangular strips are found, and these rectangular strips are called fringes, right? This is D1, D2, D3, and this is the central bright fringe. This is what? Say B1, this is what? Say B2. Is it clear or not? Like this. Copy. This is the fringe pattern. This is the consecutive bright dark fringes are obtained. Are you getting or not? Right. So now we have to find these position, the position of dark and bright fringe from here, right, in terms of D. This is the D, is the distance between the slits and the screen. These are the slits, and the distance between the two slits is small d. Is it clear or not? Okay. So okay, so how to find the positions of right fringes, position of fringes. Is it clear? So to find the position of fringes, suppose these are the S1 and S2, right? This is the point P from the central. This is the central bright fringe, right? These two sources, these two slits acts as a coherent sources. Why these are coherent sources? Because these two sources S1 and S2 act as a secondary wavelet according to Huygens principle, and these are on the same wavefront, and same wavefront mean they are in the same phase. That is why these 2 point sources acts as a two coherent sources. All right. So to find the position of the fringes, bright or dark fringes, first listen one thing. The one wave is reaching right from here, the another wave is reaching from S2 like this. Are you getting or not? So these S1 and S2 are the two sources whose frequency, right, and the phase difference is same, but this is the path x1 and this is the path x2. So this wave travel the less path, this wave travel the more path. So therefore there is a path difference. This is the P dash, suppose this is the Q, right? So S1P and PQ is same. This is the extra path traveled by the wave 2. Is it clear or not? So at P, there are two waves are reaching from the two current source, and the path difference. What is the path difference between the two wave? The delta x is what? Say x2 minus x1. Is it clear or not? This is the path difference. If I assume this is the theta, the small d is over there, right? If this is theta, if you join, okay, the sine theta here, the sine theta is equal to perpendicular upon d. So implies that the delta x is equal to d sine theta. So here the path difference is nothing but d sine theta. Is it clear or not? Copy this. So now listen. If this is theta, if I join this path, this point to this point, if this is theta, this is 90. What is this angle then? Theta 90, 90 minus theta. Therefore, this angle is what? This is 90, and therefore this angle is 90 minus theta. This angle is theta. If the theta is small, suppose this is the distance y. Are you getting or not? And this is the capital D over here. So what is the, if theta is small, then sine theta is equal to theta is equal to tan theta. Here tan theta is y upon d. So what is the path difference? Is equal to y d into sine theta may be written as y upon d. Is it clear or not? Right? Yes. Now, if this point is the position of constructive interference for constructive interference. For constructive interference mean the intensity is maximum at this point P. For constructive interference, what is the path difference? What should be the path difference? Yesterday I have calculated, or I calculated the path difference relation. It is equal to n lambda. N lambda mean the path difference must be equal to 0 lambda 2 lambda for the constructive interference. So therefore the delta x must be equal to n lambda, and this is equal to d sine theta. Are you getting or not? D sine theta. D sine theta can be written as d tan theta is equal to n lambda, and tan theta written as y upon d is equal to n lambda. So y is equal to n d lambda over d. So this is the position or the distance of nth bright fringe, right? Distance of nth bright fringe from CBF, or thus from center. Is it clear or not? Where, what is the n? N is equal to 1, 2, 3. Is it clear or not? 1, 2, 3. Listen one thing. Suppose this is the YDSE, this is S1, S2 as I told you. Although this is the central bright fringe, right? And after that there is a dark, there is a bright, there is a dark, there is a bright, there is a dark, right? There is a bright. Are you getting or not? On the other side there is a dark. Listen one thing. If you put n is equal to 0, if n is equal to 0, what is the path difference? 0. It means the wave are reaching at this point. Here the n is equal to 0, and this is the position of the central bright fringe, because the path difference x1 and x2, this is the x, this is x, both the paths are same. Therefore this is the position of the central bright fringe. So this is the CBF, central bright fringe. Are you getting or not? Next, if n is equal to 1, so delta x is equal to what? N is equal to 1, delta x is equal to lambda. It means if you consider this is the B1, this is B1 over here, suppose, right? So for this wave, what is the path difference? The path difference is lambda over here. Is it clear or not? If the path difference is lambda, so, and what is the n is equal to 1? here the y is 0, here the y1 is what? Say d lambda over d. In the same way, this is the position of first bright fringe. This is what? Position of first bright fringe. Is it clear? Copy this one. For this is the B1. Now this is the B2, second bright fringe. So listen one thing. Y1, what does it mean? This is the, if this is the B1, right? So this is the distance. This is the Y1. What is the distance of the second bright fringe? To find the second bright fringe, put n is equal to 2. What is the path difference at this thing? If two waves are reaching in this way, there will be the path difference. What is the path difference? Say 2 lambda. Is it clear or not? Here the path difference is 2 lambda. And what will be the y2? The y2 will be equal to, put n is equal to 2, so 2d lambda over d. So this is the y2. In the same way, for the finding the position of B3, this is the B3. Are you getting or not? So what is the path difference between the two waves? The path difference is continuously increasing, and here the path difference is equal to 3 lambda, and this is the position y3 from the central bright fringe. It is equal to 3d lambda over d. Is it clear or not? So in this way, from the center, the consecutive bright and dark fringe are found. So these are the distance of the first. This is the central bright fringe. This is what? Position of central bright fringe, right? And this is the position of the first, second and third bright fringe. D lambda over d, then 2d lambda, then 3d lambda over d. Copy this. So this is the position for the constructive interference. Are you getting or not? So listen one thing. This is the position of the bright fringes, right? This is the central bright fringe. This is the first bright fringe. This is the second bright fringe, and this is the third bright fringe. The distance are from this y1, y2, y3, d lambda over d, 2d lambda over d, 3d lambda over d, and so on. Are you getting or not? In the same way, now we can find the position of the dark fringe from the central bright fringe. Suppose this is the d1, this is the d2, this is the d3. So what is this distance? What is this distance? That's the thing we are going to discuss. You may write now the position of destructive interference, right? Destructive interference, destructive interference, or you can say the position of dark fringe, positions of dark fringes. Is it clear or not? Okay, I'm writing here, I'm making the figure once again, right? The position of dark fringe, suppose this is the point, again the path difference is delta x. What is the condition of the destructive interference? The path difference delta x must be equal to what? Say 2n minus 1 into lambda by 2. Did you remember or not? 2n lambda by 2 mean it should be lambda by 2, 3 lambda by 2, 5 lambda by 2, and so on. Is it clear or not? So it should be the path difference for destructive interference. How it is path difference? You tell. Listen one thing. Listen, if this is the S1 and this is S2, for this central bright fringe, what is the path difference between the two waves? Can you tell me? This path and this path is same. So what is the path difference for the central bright fringe? Tell. 0. When you move in this direction or the below the direction, so the two waves, one is reaching from this, another from reaching this. For the central bright fringe, these length and this length are same, but now this becomes small and this become big. So what is the path difference? This is the path difference. This distance is the path difference. So if this is the dark D1, are you getting or not? So you tell me, what should be the path difference? The delta x for the dark D1 delta x must be equal to lambda by 2. Are you getting? Right. So I'm writing the general expression. For the path difference, delta x must be equal to 2n minus 1 into lambda by 2. The delta x, suppose this is the theta, this is d and this is theta. So delta x must be equal to what? Delta x must be equal to, say, d sine theta. And sine theta is nothing but equal to what? Tan theta. And suppose this is the distance y. Y is equal to what? Y, tan theta is equal to y upon d, 2n minus 1 lambda by 2, 2n minus 1 d lambda over 2d. This is the position of nth dark fringe. What is this? Position of nth dark fringe from center. From center. Copy this. So I am making the figure once again for the consecutive dark fringes. If this is the S1, this is the S2, right? This is the central bright fringe. This is the first dark fringe. This is the B1. This is the D2. This is the again bright fringe, dark fringe. All right. So this is the D1, suppose. So this distance is y1. Are you getting or not? So if n is equal to 1, what is the y1? Y1 is d lambda over 2d. Is it clear or not? So this distance is y1 for the d1. For the d2, this is y2. You tell. For n is equal to 2, what is the y2? If you put n is equal to 2, 3d lambda over 2d it is. Is it clear? So this distance is y2. For n is equal to 3, what is the y3? Say 5d lambda over 2d. Are you getting or not? Listen one thing. If this, here it is the path difference is what? Say 0. What is the path difference for d1? Can you tell me what is the path difference? Here the lambda by 2. The path difference is when you will put n is equal to 1 lambda by 2. At this point, the one wave and another wave from the S1 and S2, what is the path difference? 3 lambda by 2. And for this case here, the path difference is lambda by 2. Here it is 3 lambda by 2. What is the path difference at D3? Say 5 lambda by 2. So as we are going upward away from the central bright fringe, the path difference is increasing. Here the path difference is 0. If I consider this is the B1, Sanjay, B1, what is the path difference between the two waves? Lambda. Very good. 0 plus lambda by 2 plus lambda by 2 plus lambda by 2 plus lambda by 2. It is the B2, and here it become 2 lambda. Here it become 5 lambda by 2. I think you are understanding each and everything. As we are moving away, right, from the center or the central bright fringe, the path difference continuously changing. It becomes 0 to lambda, lambda by 2, lambda, 3 lambda by 2, 2 lambda, 5 lambda. When the path difference is, if the path difference is in the form of n lambda, 0 lambda, 2 lambda, 3 lambda, here the intensity is maximum. Here is the maximum, maximum, maximum. And when the path difference is lambda by 2, 3 lambda by 2, 5 lambda by 2, intensity reduces to 0. Here the intensity is 0, here the intensity is 0, and here the intensity is maximum, maximum, like this. And this I will write, this is the y3. Is it clear, Sanjay? Copy this. So this is these are the position of the consecutive bright and dark fringes, right? So this is called the interference. Are you getting or not? Listen one thing. When Young performed this experiment, all right, so we are considering these source of light acting as a wave. Are you getting or not? These sources are acting as a wave. Therefore, light assumed to be wave, and because of the because of the interference on the screen, we are getting the consecutive bright and dark fringes. Is it clear or not? So now we consider the fringe width. Fringe width. Fringe width. This fringe width is represented by beta. What is the fringe width? Fringe width is the distance between two consecutive distance between two consecutive either bright fringes, or dark fringe. Is it clear or not? So this is the fringe width. This width is called the fringe width. So look at the figure. Suppose this is the bright fringe, this is the dark fringe, this is the bright, this is the dark, this is the bright. Are you getting or not? Here dark, bright and dark like this. So you tell me, if you consider the D1 and D2, so D1 distance is what? Say d lambda over 2d, and D2 distance is what? Say 3d lambda over 2d. Are you getting or not? So fringe width is considered the distance between two consecutive dark fringe D2 and D1. So 3 lambda over 2d minus d lambda over 2d. So which is equal to d lambda over d. Or for dark fringe, dark. Listen, if this is the B1, this is the B2, right? You may write this the D1 and this is the D2. In this side, this is the B1, this is the B2. So what is the B1 distance? It is equal to d lambda over d. What is the B2 distance? It is over 2d lambda over d. So when 2d lambda over d minus d lambda over d, for bright fringe, the fringe width is equal to 2d lambda over d minus d lambda over d. So this is equal to d lambda over d. So what is the fringe width formula? The fringe width formula you may write d lambda over d. Is it clear or not? Copy this. Okay, so you tell me the fringe width depends upon what? The fringe width depends upon, right? Fringe width depends upon first, right? D, beta is proportional to d, directly proportional to lambda, and inversely proportional to small d. As distance is increased, the beta is increased, wavelength is increased, beta is increased. Distance between the slits S1 and S2 is increased, then the size of the fringe width will reduce. Are you getting or not? Copy this, copy this. Listen, okay, listen one more thing. If this experiment is done in a liquid of refractive index mu, are you getting or not? So the wavelength of the light is lambda by mu. So therefore the beta is what? D lambda dash, beta is equal to d lambda dash over d. Are you getting or not? So lambda dash is what? Mu into d. So beta dash is equal to beta by mu. So if all this experiment is kept in a liquid whose refractive index is mu, that is fringe width will decrease. Is it clear or not? The fringe width will decrease. Copy this. This is the fringe width. Fringe width means this is the width, right? So this is the consecutive distance, right? The distance between two consecutive fringe. Now this is angular fringe width. Angular fringe width. Angular fringe width is represented by omega, right? What is the angular fringe width? Listen one thing. Suppose these are the slits, right? And this is the bright fringe. Are you getting or not? So what is the fringe width of this bright fringe? Say beta. So what is the angle made by this fringe on the slits, right? So S1 S2, the angle made by fringe, angle made by fringe on the slits is called angular fringe width, is called angular fringe width. Angular fringe width. Is it clear or not? So therefore, if it is D, what is the angular fringe width? Theta is equal to angle beta, angle is equal to arc upon radius. What is the value of beta? Beta is d lambda over d divided by capital D. So theta is equal to lambda over d. So this is the angular fringe width. Do you understand or not? Right. So it depends upon right, wavelength of the light. Wavelength of light. Lambda upon d. Copy this. Listen one more thing. I will make another figure, very important figure, right? For example, listen one thing. The intensity. If we consider the intensity, right? Intensity. Listen one thing. If this is the two slits, right? The slits are of same width, the same type of slits are there. So its intensity is I naught, intensity I naught. When the two waves propagate in the medium and when reaches to the some point, is it clear or not? So what is the resultant intensity? It is equal to 4 I naught cos square delta phi by 2. Is it clear or not, you tell? Or the resultant intensity may be written as, right, it is okay, because the resultant intensity we come from I1 plus I2 plus 2 root I1 I2 cos delta phi. Is it clear or not, Sanjay? But it is the special case we have done when the intensity, both intensities are same. So the resultant intensity given by this, right? Listen one thing. Suppose this is the central bright fringe, this is the dark fringe, this is again the bright fringe, this is the dark fringe, this is the bright fringe, this is the dark fringe, and this is the bright fringe. Assume. Is it clear or not? Yes. Listen. Very good. Here, what is the path difference? Say 0. So delta phi is equal to 2 pi by lambda into delta x. If the path difference is 0, what is the phase difference over here? For this central bright fringe, 0. For this D1, what is the delta x? You tell. Lambda by 2. What is the phase difference, you tell? Lambda by 2, it is pi. For B1, what is the path difference, you tell? Lambda. What is the phase difference? 2 pi. For D2, what is the path difference? What is the phase difference? For B2, the path difference and delta phi, this is the D3, the delta x is, delta phi is 5 pi. Is it clear or not? Listen one thing. If the two waves are reaching at this point from here, right? Listen one thing. If delta phi is equal to what? Delta phi is equal to 0, 2 pi, 4 pi, right? For bright fringes, what is the delta phi? You will say 2n pi. 0, 2 pi, 4 pi. Are you getting or not? 0, 2 pi, 4 pi like this. So if delta phi is, then what is the resultant intensity? You tell. Can you tell? Resultant intensity IR will be equal to 4I naught cos square 2n pi by 2 4I naught cos square n pi, and this is equal to either plus 1 or minus 1, it is a square, so 4I naught. Is it clear or not? So here the intensity is what? Say 4I naught. Intensity is also equal to 4I naught. Intensity is equal to 4I naught. Intensity is equal to what? Say 4I naught. Is it clear or not? But for dark fringe, you tell. The delta phi is equal to what? Say 2n minus 1, right? 2n minus 1 into pi. Are you getting or not? It will be what? Say pi, 3 pi, 5 pi. So what is the resultant intensity? Resultant intensity. Yes, tell. 4I naught cos 4I naught cos square delta phi by 2. 2n minus 1 into pi by 2. Are you getting or not? So this 2n minus 1 pi by 2 is always 0. So the resultant intensity is what? 0. So here, that is why it is called the 0, dark. This is the dark 1, dark 2, dark 3. So as we are moving in this case, the resultant intensity is maximum. Then it is again maximum. It is again maximum. It is again maximum. Right? It is again maximum. Is it clear or not? Like this. So the intensity varies like this. So if you draw the graph between the intensity, the graph of the intensity is varies from 4 at every bright fringe. The intensity is what? Equal to 4 night. Dark fringe 0, 0, 4I naught. Then it reduces, then it increases, reduces, increases. So this is the graph of the intensity. Are you getting or not? Copy this. So from this expression you can find that as the distance is increasing, the intensity is increasing. Listen, it is not always fixed. It is not always 4I naught and 0, 4I naught and 0. No, the intensity may vary from 4I naught to 0. It may be 3I naught, it may be 2I naught, it may be the I naught. Are you getting or not? As the distance is changing, the intensity is changing. Is it clear or not? For example, if this is the distance y, suppose in terms of y, so delta phi is what? Say 2 pi by lambda into delta x. Are you getting or not? This is the path difference. And what is the path difference? If this is the y, the path difference you can find. This is the path difference. Is d sine theta is equal to d tan theta, and d tan theta is equal to what? Y upon d. So delta x is equal to y upon d. So delta phi may be written as 2 pi by lambda into dy upon capital D. Is it clear or not? So it is equal to 2 pi by upon d lambda over d. So it may be written as 2 pi by upon beta. So this is the delta phi. So here the resultant intensity can be written as, this is the 4I naught, this is the maximum intensity, and cos square delta phi by 2. Delta phi mean 2 pi by beta, 2 will cancel out. So 4I naught cos square pi by beta. This is the resultant intensity formula. Listen one thing, as suppose this is the intensity versus y graph. So intensity versus y graph, it is similar to the cos square y graph. So the cos square y graph is what? This is the graph of the cos square y graph. Is it clear or not? like this. So the maximum intensity is what? Say it is 4I naught 0, 4I naught 0. Are you getting or not? You put the distance y, any distance y, you can find out the resultant intensity. Are you getting or not? For example, listen one thing. This is the D1. What is the y for D1? You tell. Say beta by 2. Are you getting? Right. This is what? Say beta by 2. This is what? Say 3 beta by 2. This is what? Say 5 beta by 2. Are you getting or not? For the bright fringe, what is the distance? Beta. For B2, it is 2 beta. Is it clear? So if you put beta by 2 over here for D1, the resultant intensity 4I naught, I am just putting the value cos square pi into beta, y is beta by 2. So it will cancel out 4I naught cos square pi by 2. It is 0. So the resultant intensity is what? 0. So in this formula, if you put the different value of the y, you can get the resultant intensity. And this resultant intensity, this is the y-axis, it is varying like cos square y. So cos square y is graph like this. Did you remember? Listen, this is the graph of the cos x. This is the cos x. And if you want to make the graph of the cos square x, the graph of the cos square is like this, if you remember. So that is why the variation of intensity like this is the intensity versus y variation given in the question. Many questions are asked for this based upon this formula. So copy this. So on this basis you can do some questions, right? For example, listen one thing. Find the position, right? For example, find the minimum distance from central bright fringe in YDSE, where the intensity is half of the maximum intensity. Are you getting or not? This is the question, right? So they are asking the distance. Listen one thing. Suppose these are the YDSE, this is the YDSE, this is the central bright fringe. We are going to find the distance, the minimum distance. Here the intensity is what? The maximum intensity is 4I naught, suppose, right? So the intensity, minimum intensity becomes 0, but this is the distance we have to find, and this intensity is what? Say 2I naught. Do you understand or not? The intensity is reducing from 4I naught to 3I naught, 2I naught, I naught, and then 0. So how to solve this question, Sanjay? You tell. We can use either this formula, right? Solution I am writing here. After this you can write the resultant intensity is 4I naught cos square pi by beta. So what is the resultant intensity we have to put? At this point the resultant intensity should be the half of the maximum intensity. This is 4I naught cos square, right? So this is 1 by 2 cos square. So this is 1 by root 2. Is it clear? So this is cos pi by 4. Are you getting? So this pi by 4 is equal to pi by beta. So what is the distance? Say beta by 4, or sometime it may be written as 1 upon 4 d lambda over d. This is the distance. Are you getting or not? Sanjay, this distance is what? Say beta by 4. Listen, this is the this distance is what? Say beta by 2, and this distance is what? Say beta by 4. the intensity become half of the maximum intensity. Although there will be so many distances where the intensity is what? 2I naught. But the minimum intensity from the central bright fringe we have to find. Copy this. So read this question, and in this question the laser light, right? This is the illustration number 6. I am writing the solution. What is that? The wavelength is what for the laser light? 630 nanometer, right? This is 630 nanometer. The fringes are separate, pattern in which the fringes are separated by, so it means the separation beta is given as 8.1 millimeter. A second laser light produces an interference in which fringes are the separated by, so beta dash is given as 72 millimeter. Calculate the wavelength, so its wavelength we have to find. So what is the beta? Beta is equal to d lambda over d, 8.1 millimeter. What is over here? The distance d between the screen and the slits, lambda dash upon d is equal to what? 722 millimeter. Equation number 1, equation number 2. What we have to find? Lambda dash. So divided by 2 and 1. D lambda dash over d divided by d lambda over d is equal to 7.2 upon 8.1. Is it clear? Right? So note 72 noni 81. So lambda dash upon lambda is equal to 8 upon 9. What is the lambda? Is equal to 8 upon 9 into lambda. 8 upon 9 into 6 3. 9 7 63 7 560 nanometer is the wavelength. I think you are getting this solution. So read this question. It is the illustration number 7. I am writing the solution. What is given? If this is the slits, suppose that when the light is incident, the wavelength is given as the 6000 angstrom. Is it clear? The slits are separated by the d is equal to what? 0.1 centimeter. Is it clear? The angular position of 10th maxima. So this is central bright fringe, this is B1, B2 and so on, this is the B10. So this angular position theta you have to find. Are you getting or not? So can you tell me what is this distance of the B10? Yes, this is 10 beta, that's it. A beta, 2 beta, 3 beta, 10 beta. What is the beta? D lambda over d, and this is the capital D. So what is the tan theta now? Tan theta is equal to tan beta perpendicular upon base is equal to d lambda over d upon capital D will cancel out tan lambda over d. Is it clear or not? So for the small theta, the tan theta is nothing but equal to tan theta. Lambda, what is the wavelength? 6000 into 10 to the power minus 10. What is the distance d? 0.1 into 10 to the power minus 2. Right, 6 into 10 to the power minus 6 divided by 10 to the power minus 3. 6 into 10 to the power minus 3 radian is the angular position of the 10th maximum. So this is the first part. What is the second part you tell? Beta they are asking. The separation between two adjacent minima is nothing but d lambda over d. So separation between two adjacent d lambda over d. What is the d? 1 meter. It is 1 meter. 1 into lambda. What is the lambda? 6000 10 to the power minus 10, right, divided by 0.1 centimeter. So this is 6 into 10 to the power minus 7 into 10 to the power 3, right? So 0.6 millimeter is the separation between two consecutive minimum. That is the fringe width is asking in the question. Copy this. So read this illustration. This is, I am writing the solution. Yes, in this question YDSE in this YDSE, what is given? D is equal to 1 meter, and the slit separation is given as 0.12 millimeter, right? The third distance of the third dark band from the central, okay, this is D1, D2, and this is D3. I think you are very well aware, D1, D2, D3. Listen, how to remember this? It is beta by 2, it is beta by 2, 3 beta by 2, and this is 5 beta by 2. Did you remember or not? Beta by 2, 3 beta by 2, 5 beta by 2. So in the first question, the distance of the third dark band from the central bright fringe is nothing but 5 beta by 2, 5 by 2 d lambda over d. The wavelength used in this experiment is 6000 angstrom. So you can put the value and you can get the answer. 5 by 2, 1 into 6000, 10 की power minus 10 upon 0.12 millimeter, right? So when you will calculate this, you will get 1.2 centimeter. This is the position of the third dark fringe from the central bright fringe. Second, the distance of third bright band from the center, okay, this is D1, this is B1, B2, B3. So you can tell me in terms of beta,